Hi, Professor. My name is Imaz Usman.
And my name is Pilani Moyo.
I'm Sajid Olamazader.
And I'm Shalmi Nasir.
And this is our final course project for CITM618. So the objective of the presentation. In this project, we're working with a data set that's related to a direct marketing campaign of a Portuguese banking institution. The marketing campaigns were based on phone calls. This report compares the results of the four classification techniques, which will be applied to the given data set to evaluate the best classifier. The process involves multiple steps, which include pre-processing the data and cleaning and preparing the data for processing. Given the data set, we apply each classification technique and evaluate the results using the following scores: accuracy score, recall, precision, error rate, and F1 score. Our goal given the data set is to predict whether a given client will subscribe to a term deposit or not. Introduction. So the challenge, again, is predicting whether the client will subscribe to the term deposit or not. Y is the target class. With the bank.csv file as a starting point, we'll utilize our program to draw a conclusion. In order to select the best classifier for this data set, we must employ the four machine learning models listed below to gather statistics on accuracy, error rate, precision, recall, and F1 score. So methodology. So the methods that were used to analyze the data are decision tree, support vector machine, linear classifier, and KNN. These are the four classifiers with the description beside them. And now I'll pass it on to Falani.
For the experiment design, we'll use a divide and conquer approach in our experiment design. Following the early data cleaning and preparation phases, we will carefully divide the remaining duties. We will start by finishing the code for each classifier individually. We will concentrate on the code for the confusion matrix once we've verified that each classifier operates appropriately. Once the matrix coding is complete, we will apply to each classifier to get the metrics required for comparison and ranking. Description of the given data set. Data from the bank customers make up this data set. There are 17 input variables, and the goal is Y, which indicates whether the consumer enrolled for a term deposit or not. There are 17 columns and 45,211 occurrences or rows before any cleanup. We will now go to some informational data facts. Below are the given dataset summary statistics. Age, balance, and duration all have standard deviations of 10.61, 3,044.76, 257.52 correspondingly. Okay, if we can move to the next slide. The dataset description. This is the process that we went through to do the data cleaning. The bank CSV data file is in a string format. We put the file in Excel and we use the column wizard to arrange the data into columns. After formatting into columns, there were 45,211 rows with 17 columns. The column outcome was removed along with all rows containing unknown values. After removing the column and unknown entries, we're left with 30,907 rows and 16 columns. We use the 80-20 split to prepare the data sets. That is 80% of the data set goes into training set and 20% goes into the remaining test set. To split the data, we'll be using the train test split from sklearn. The train test split randomly distributes your data into training and testing sets according to the ratio provided. And next slide. After we completed preparing the data, there are 7 columns containing numerical values. The mean age of the data set is 40.92. The youngest age is 18 and the oldest is 95. The average yearly balance is 1,425.76. The mean number of contacts performed before this campaign and for this client is 0.81. The rest of the data set can be seen in the diagram below. If we can move to the next column. So for the results that we achieve, I will pass you over to Sam to give a breakdown of the results.
Okay, so the result that we achieved from the experiment has very high accuracy. All four classifiers rank high in terms of accuracy. It should be noted, however, that since we encountered challenges building a linear model, we used a logistic regression model instead. So in the linear model, the accuracy is 86.412, KNN is 85.975, and CVM is 85.943, and decision tree is 85.345. The error rate in our data set is very low since we have the high accuracy. The error for linear is less than 14%, but for the rest of them are higher than 14%. The precision is the ability of our classification model to identify only the relevant data points. It expressed the proportion of the data points our model says existed in the relevant classes that were indeed relevant. So in all four classifiers, for decision tree, we have the highest of 0.91, and for KNN, we have 0.89, linear 0.87, and CVM is 0.86. So for the results, I pass to Shulamit to continue.
Thank you. The recall only focuses on how the positive samples are classified. When the recall is high, it means our model can classify all the positive samples correctly as positive. The four classifiers have the following recall scores: SVM 0.999, linear 0.981, KNN 0.95, decision tree 0.913. The high score means that our models can be trusted in their ability to detect positive samples. Next slide, please. The F1 score combines the precision and recall of a classifier in a single metric by taking their harmonic means. The four classifiers have the following F1 score: linear 0.925, SVM 0.924, KNN 0.921, decision tree 0.914. All four have high scores, indicating that the model predicts over each observation correctly. Next slide, please. Conclusion: the linear model is chosen because it has a high F1 score. The F1 score is the go-to metric by measuring the performance of classification models. This is mainly due to its ability to rely actually performance on balanced and imbalanced data set. In addition, the F1 considers both the precision and the recall ability of the model, making it well-rounded assessor of model performance. And this brings our presentation to its conclusion. Thank you so much, and I hope you like it.